Today's lesson is on finding square roots. A square root is a number that when multiplied by itself equals that given number. When you have a perfect square, it's a number with integers as its square root. So if you think about like the number 25, 5 times 5 is 25. So that's considered a perfect square because 5 is an integer. Your radical sign, that's this piece right here. And what that is it represents square root. Your radicand is the number under your square root. So a square root has actually like two different kind of roots. It's got that positive square root. So if you look at the square root of 14, or excuse me, square root of 16, it equals 4. Well, the negative square root of 16 is negative 4 because negative 4 times negative 4 is also 16. This here indicates, when you see this considered a plus minus sign, it indicates you want both the positive and negative value of the square root of 16. So looking down here now, and you're asked to find the roots. In letter A, it says find the square root of 25. So because 5 squared is 25, that means, I'm trying to change colors here, that the square root of 25 is considered to be the square root of 5 squared. That's the value that's going to create 25. So your answer for that is 5. If you have negative root 9/16, you look at it as being, okay, let me look at my numerator and my denominator and say, okay, well, they're both perfect squares. So the square root of 9/16 is going to be 3/4, because if you took 3/4 and you squared it, meaning you took 3/4 times 3/4, you're going to get 9/16. But because you have that negative sign out in front, it means it wants that negative root. So your answer for this one is going to be negative 3/4. And you look at letter C, it has plus minus the square root of 2.25. So your radicand can be a decimal. It can be that fraction as well. So you're going to look at this and you're going to say, all right, well, I know that 1.5 squared is going to give me that 2.25. Therefore, the square root, the plus minus square root of 2.25, is the plus minus square root of 1.5 squared, which is 1.5 and negative 1.5. When we write it, you can absolutely write that answer as plus minus 1.5. So the next piece we have is this. So finding those square roots. When you're using a calculator to do this, which you're more than welcome to, you will use that square root button. So if you're looking at the square root of 36, it's going to be 6. Okay, this is saying I want that positive root, okay, because there's no negative or plus minus outside. So it's like saying, all right, I know 6 squared is 36. So this is saying take the square root of 6 squared, which is going to give you that 6. Okay, pause the video, and I want you to try numbers 2, 3, 4, 5, and 6. So you'll see that in number 2, the square root of 10 squared is equal to 10. Number 3, the square root of 11 squared is equal to 11. Negative root 9 squared is equal to negative 9. Plus minus 2/5 is number 5. And then 3.5 is number 6. So when you can use these and you can evaluate an expression that involves square roots, they fall. So when you're evaluating that expression, they fall in line with the E in PEMDAS. So you're always going to do parentheses first, and then you are going to do exponents. But if you don't have exponents and you do have roots, since they are kind of opposites of each other, inverses, excuse me, that was the word I was looking for. They're inverses of each other, which is why when we wrote it up here, you can write negative root 81 as negative root 9 squared, because squaring something and square rooting are inverses of one another. So when you look down here and you go to evaluate an expression that has a square root, you're going to evaluate that square root first. So you'd evaluate this piece first. When you have what's called 5 root 36. You're looking at this root 36 as like a variable. And when you have a number smacked right up against it, that means multiplication. So here, what it's saying to you is, I want you to take root 36 first, which is 6, and then times it by 5, and then add 7. So now you have 5 times 6 plus 7. So you evaluate that square root first, then you multiply 5 times 6, and then you add. So the same process is going to fall as you continue on down. If you look at letter B here, I like this one. It's 1/4 plus the square root of 18 halves. Now, you could look at 18 halves and say, oh, well, 18 is not a perfect square, nor is 2. However, if you actually did divide 18 halves, you're going to get 9. And then the square root of 9 is going to give you that 3. Okay, so then you're going to take 1/4 plus 3. Letter C is saying, okay, well, I want you to actually square root, so evaluate the power using inverse operations. You're going to square root 81, and then you're going to square it. So you're basically just negating both of those pieces. So it comes out as the number 81, and then you're going to subtract 76. So pause the video. I'm going to add into these here, the next couple. And I want you to try these. So in number 1, you're going to have to do the square root of 25 first, and then evaluate. Okay, so in number 1, you should have gotten -3. In number 2, you should have gotten 4.4. And in number 3, you should have gotten 11. So this last piece then is, here we go, real life application. So the area of a plate is 78.5 centimeters squared. What is the radius of the plate? Remember that the area of a circle can be found by using the formula A equals pi r squared. So we're going to evaluate this by substituting what we know. Well, we know that the area of that plate is 78.5 centimeters squared. So since area is pi r squared, we're going to actually plug in 78.5 where the A is for area. Pi is always 3.14 when we're doing these problems. And then we're looking for your radius. So that's going to remain as r squared. So we're going to solve and we first plug in, and then we solve for r squared. Well, all right, so we divided 3.14 on both sides, so you get 25 equals r squared. Since the inverse of squaring is square rooting, we're going to do the opposite operation, just like we always do, even in a one-step equation. So square root r squared on both sides, square root on both sides. So you're going to get r's value is 5. So try that with this next one, having the area of a circular rug. So remember, A equals pi r squared. Okay, you're going to write and solve the equation to find the radius of the rug. So plug it in and then solve it. Pause the video. So you should have gotten the radius is 30 feet. So today's lesson is all about square roots and that radical sign and the value underneath your radicand, or your radical sign, which is called your radicand.